Okay, so areas of shapes. So here we're looking at rectangles and rectangles that have had other rectangles taken out of them. So we have a little tiny formula here, which is length times width gives us the area. So if you remember when we were working on perimeter, we would add all the distances around. With area, we multiply the length times the width. So here we have a length of 8 centimeters and a width of 5. Now, it doesn't matter which one you call the length and which one you call the width, but you multiply these two together. So 5 times 8 is 40, and that will be centimeters squared, because centimeters times centimeters gives us centimeters squared. If you multiply anything by itself, then it's squared. Okay, so if we were dealing with meters, it would be meters squared, kilometers, kilometers squared. Now, the reason that this works is that if I divided this 5 centimeter line into 1 centimeter parts here, okay, not very even, but we've got 1, 2, 3, 4, 5 here, and then I drew lines across, and then I did the same 1 centimeter rows here. What we would get is little blocks that are all 1 centimeter by 1 centimeter. And of course I'd have 8 this way and I would have 5 this way. So if I added all these little squares together, I would end up with 40. So these squares would be 1 centimeter by 1 centimeter. So 1 times 1 is 1, and we would have 40 of them. So 1 times 40 is 40. Okay, now if you're not quite sure what I've said, or I've not explained it very well, then it's quite simple. We just multiply length times width. Okay. So with ordinary rectangles, this is nice and simple. Sorry. So let's take a shape here. So this is not quite so simple, so it must be more difficult, mustn't it? Now it really isn't. What I do is this. I put in these lines, and you're quite, everybody's quite okay to do this. And I say, okay, this piece has been cut out. So what would be the area of the rectangle had this piece not been cut out? Well, the widest dimension is the 12, and the widest dimension here is 9, so length times width, so that would be 9 times 12, so 9 times 12 gives me 108. So now all I've got to do is find out what this part is here, and then take it away. So I know that this distance is 12. I know this distance is 6. So 6 from 12 means that this must be 6 centimeters long, because 6 plus 6 will give me the 12. Now this distance here is 9, and this distance here is 5. So 9 take away 5 gives me 4. So this distance here must be 4 centimeters. 5 plus 4 gives us the 9. So now I know the length and width of this little rectangle. So 6 fours are 24. So 6 times 4 is 24. Now this piece has been cut away. So I need to take this away from the overall rectangle. So 108 minus the 24. Now remember, these are both centimetres squared now because they're both areas. So 108 less the 24 would be 84 centimetres squared. Okay, you could do a little sum on the side here just to prove that it works. So that's how we can do this. Now if we take this one, a piece has been taken out of the middle. Okay, so I just do exactly the same. I pretend that this piece is still here. So the whole rectangle here is length times width, so that will be 12 times 8, okay, which I know is 96. Now the width of this, or the length of this, is 4 meters, and the width is 1 meter. So that's already been put in for me. I haven't got to work anything out. So this little area here that's been cut out is 4 times 1, which is 4. Now remember, we're dealing only in meters here, so this is meters squared, and this piece has been cut out, so we're going to take this away. So 96 take away 4 is 92, and that will be meters squared, and that will be the answer. So if we work on the fact that the whole shape is actually there, work out that area, calculate the part that's been taken off, then that will give us our answer. Okay? Then you can, if you want to, divide the shape into 2 rectangles. So here we would have a rectangle 6 times 9, and here we would have a rectangle 6 times 5, and we would add the 2 together and we would still come up with 84. Now this is fine, there's nothing wrong with that until we get to slightly more complex shapes. So choose whichever method you choose, but I would strongly advise this particular method. Okay, so again, as I always say, it's just practice, so give it a shot and you'll be fine.